Hi, my name is Göran Rydqvist. I am the co-founder and CTO of Configura. I have been coding all my life, a period which pretty much actually coincides with the birth of the Apple II microcomputer. I would like to share a story of going against all possible odds. Imagine two guys in my father's summer house, and they knew exactly what to do. Or rather, imagine this vast expanse of blackness, and in that vast expanse there is this tiniest of little flames. And that was our knowledge. So how did you end up in this situation? Well, my father, Rydqvist, he was running his own office partition business in the 80s, and he recognized already at the time that this industry really needed computer assistance to do space planning, system configuration, and specifically calculation. That was the key. So Johan and I, we took on this problem, and our initial vision was immediately to have these animating objects that would snap together. They would understand what they were, so they could report and calculate correctly. They would find corners, they would flip around and take away the selection problem of finding exactly the right thing from the start. So this sounds really easy by 2020 standards, but reality check. The year is 1990. No C++, no Java, no C#, just plain C. No internet, no Google, no Wikipedia, no GitHub. What can you do? No Windows, only DOS, right? Text terminals. Well, there was the Sun Spark stations, and that's where we started. We had these two 16 megahertz, imagine, computers, and there were graphics screens on them, and we wanted to do animation. So we had coffee, food, and tons of enthusiasm, and a very thick skin to protect us all from reality. So to try to understand the problem domain we were going into is that it is surprisingly large and challenging. It's nothing, you just don't just write up a little program and then it's done. And we quickly realized that the programming language at hand, which was C, was not very well suited to the problem we wanted to solve. So we went instantly about this and tried to adapt C into the style we wanted to code in. And so we started to do a heavy text expansion, and then we broke the tools that were available. So we had to create our own tools. And this made us very productive. And the productivity resulted in that we created lots of code, the source code, and this started to take a long time to compile into an exe file. This exe file is then started up, and you can see the result of your change in the program. So the dream was born. The dream was born to have a programming language where you could do a change in the running program. And there were some languages available where you could do this, but they were slow. They were too slow to execute on the computers we had, so it was not really an option. When creating a computer software in C, you compile each source code file into machine code, and then a linker builds the exe file, and then you can finally start up the application. After starting the exe file, you navigate into your test context, and then you can perform your test. Then you repeat until you sleep. So there's a lot of these experiments to understand what's going to happen in the final result. The tools we built made us very productive, and we quickly created so many source files that our build times would become a full minute. Great software requires a lot of experimentation, especially when you have these soft aspects to try to make a very user-friendly software. So this quickly became very frustrating, and we felt that this would be a major bottleneck that would stop us from realizing this vision of a fantastic software. So the dream was born, a programming language that allowed us to change instantly into the running program. And the only programming language that we were aware of that supported this were dead slow, so they would not support interactive applications with animating objects. Well, I can say we worked a lot, and we pushed really hard to get to our goals, and we did barely. I frequently got some nightmares, and I have a couple of favorites. One of them is a very, very stressful situation of trying to pack my bags half an hour before the flight leaves, but there is an hour transport to the airport, And then there is a variation when I get to the airport, and the bag is like 60 kilos, so you can barely move without breaking a sweat. And then there is this labyrinth of staircases and stairwells, so you have no idea, and no signs, of course. And the last favorite is walking around in mud. This led us into a series of experiments. The first one started in 1995. It was the Z interpreter. So I tried coding the absolutely fastest way to build an execution machine myself. So you pretend you're a processor, that's what an interpreter is. But we couldn't get it fast enough, even using all the tricks in the book, so we discarded it. In 1997, I started using Java to build, and I built a compiler which produced bytecode and class files, and Java was built to load these class files, and so I could get that to work, and then it would execute the code. But it would not update if something was depending on something else. We had to discard that route as well. In 1998, I sat over Christmas, and I thought, grab a piece of memory and put some bytes in there, actually specific bytes, that is the machine code itself. There was machine code to add two numbers together and then return them. And then I told the C programming language that this is a function, and then I call that function, and I got it to add that number up, and I could print the result. I said, this was easy, now I can do this. So we started. But you know what I did in school? Did I go the compiler course? No, I skipped out of it because I thought it was too academic. I didn't think they were teaching the right things. So it's not so easy to build a compiler. It happens to be one of the most challenging problems in computer science. So between 1998 and 2000, two other programmers, Magnus Carlgren and Staffan Lindroth, came on board and joined me, and they frustratingly tried to use my quite bad compiler, because suddenly if they added some code, it would crash on the way up. So we had a lot of trouble with that. But then in the year 2000, I started a full rewrite of the whole thing, and then we got up to the version that we're using today. Why was it named CM, the programming language? Well, it wasn't really. We looked at the big brother Apple and these guys, and they always had these cool code names on their projects. So we code names are to magic, and then it was C-like, so it became CM. So at the break of 2000, I realized there were fundamental design flaws in the first version of the compiler, so I threw it all away. And I spent about 5 weeks at 50 to 55 hours of hyper concentration. And finally, at the end of 5 weeks, I got 1+1 working again. And then I took a short break because my quality levels were slipping. I could feel that. Major design decisions of the CM programming language were, it was targeted. We all had the idea from the start that we would want partner programmers to use it. So they had to be friendly to the programmer. So we needed a mechanism called garbage collection and other called bound checking. So you're not allowed, these two mechanisms will protect you from doing silly mistakes which are really hard to debug. So the bound checking is really easy, but garbage collection, that's hard. And I had not a lot of ideas of how to solve this problem. The only techniques I knew about, they would stop the world, and this is not very, there would be a long pause when it collected the memory so it could be reused again by the application. So this was not a very good thing to use. After many struggles, we got contact with this English company with some enthusiast guys there who had developed something called the MPS, a memory pool system. This was a garbage collector library that I could plug in and start working with. But this was a beast to work with. The closest description I can give is, the fantasy setup. If you're going to conjure a demon up, then you have to write your spells and you waltz around you in glowing glyphs. And then the magic user stands in the middle. And then when the demon comes up, he tries to tear through to eat up the magic user, because of course you don't want to be a slave. And this is a garbage collector. It moves everything around all the time. So you make the tiniest little mistake in your 300,000 line code, and it will tear it apart instantly. And it would be really, really hard to debug. This drove us to invent a lot of new and innovative debugging strategies that would help us to uncover all the strange bugs and the troubles that we encountered. So we grow a lot in strength doing this process. And so by doing this, we were able to push forward and keep going, and we got the Swedish kitchen manufacturer Marbodal interested in replacing their design tool with what we had to offer instead. And so from that point, this very intense work of building up a kitchen extension as well started. Was there no more trouble on the horizon? Yes, of course there was. When everything else was becoming stable, suddenly we started to get crashes in the 3D view. They were very random, so it was really hard to repeat. We could really not ship this application out to 500 plus users, which was at hand. It was close at hand at the point. So this was breaking. What can we do from this point? Well, one of the worst bugs I ever encountered, because it was inside this code from the graphics vendor, which I couldn't touch. It was just pure machine code. So Staffan invented this thing we call the stack dive, and it simply creates a lot of space. So it calls a function again and again and again, and then we call out to their function because we noticed it would crash on the way out, on the way back. And then we got a repeat. So from the repeat, when we could repeat it every time, and we could start to imagine how to debug it. So we started single stepping into their machine code, but looking at machine code, it's myriads of it, and the processor is really fast. It's really hard to understand anything what's going on at this point. But then we came up with the idea to copy the stacks. We made a copy of the stack, and then for single stepping into their machine code, we would compare the stacks. We could get an instant detection on when the stack changed, because we know they were destroying the stack backwards. So when our functions returned, it would crash. Then, with a lot of patience from that point on, we managed to single step into our code and prove exactly what instruction that did the overwrite. So I took my full-size computer on an airplane. It was not too easy. I carried it around the subways in London. I took it on the train out to Sheffield. I got it up and running in their office, and 20 minutes later, their programmer had found the bug, and it was a really terrible bug on their side. Well, at least they bought me dinner for the trouble, and I could sweat my way back home again. At this point, we were able to complete the Marbodal kitchen extension. So we managed to get it fully up and running in 2003, and this has to be considered a monumental feat, considering 3 dedicated programmers doing the programming language compiler, the whole development environment, the CET developer core, the CET designer itself, and the Marbodal kitchen extension. It was very exciting times, and we even got programmers on their side to help in the process. So our vision was coming through. Was this the end of trouble? No, not really. By 2008, our graphics engine started to look really dated. So we got in contact with this little French company who did something called the Red graphics engine. It was a great engine, it was very impressive, but it was also very low level, so there was so much trouble in getting our software to work with it. And the graphics drivers at the time were terrible, and so just by using the software, it would suddenly crash very badly, and there was no end of this trouble. So I had a constant lump in my stomach of just waiting for these crashes to roll in or not. But luckily now by 2020, all of this seemed to have matured. The whole industry has matured, and graphics drivers are now quite good. So this trouble is, I think, behind us by now. The morals of my story is that there are very few things in life where you can be sure about the outcome. However, I am sure about this specific outcome. The Configura story is here to stay because of this fantastic Configura community and because it just makes so much sense. Let me introduce to you our next speaker. Someone has cared about our community since joining Configura as one of the first American employees 13 years ago, our VP of Customer Experience, Tracy Lanning.